In 1845, the physicist Michael Faraday was conducting an experiment to find the relation between electromagnetism and light. And he discovered that the light is actually an electromagnetic wave. But all started to believe it was false. And 10 years later, a student, James Maxwell, started thinking about them. And in 1884, Maxwell proposed some beautiful equations showing the relation between electricity and magnetism. And later, scientists developed these equations into this modern form using vector calculus. From thereafter, these four Maxwell equations are vital in the field of electromagnetics. According to Gauss law, integral EDA equals charge enclosed by epsilon naught. And we already know that Q, which is charge, equals rho times V. Here, Q is the charge enclosed, V is the volume charge density, and its units are coulomb per meter cube, and V is volume. And from divergence theorem, integral EDA equals double integral of del dot EdV, where del dot E is the divergence of an electric field. And by using this, we can convert the line integral into volume integral. And Q equals rho V. Differentiating the Q gives dQ equals rho times dV. And finally integrating this dQ, which is Q, equals integral rho dV. Applying this in the Gauss equation, we'll get integral del dot E dV equals integral rho dV upon epsilon naught. And from that we can get del dot E equals rho by epsilon naught. This equation where del dot E is the divergence of an electric field is equals 1 by epsilon naught times the volume charge density, which is rho. It is a Maxwell's first equation. And while coming to Gauss law in magnetism, integral BdA equals 0. And by applying the divergence theorem, integral del dot B dV equals 0. And from that we can get del dot B equals 0. And it is the second Maxwell equation. Here del dot B is the divergence of a magnetic field is always 0. And the meaning of this equation is monopoles doesn't exist. If we cut any magnet into n number of particles, it forms a new north pole and south pole as well, but it cannot form a single pole. That is the meaning of the Maxwell second equation. Del dot B equals 0.